What you are hearing is not a soundtrack. It is the heartbeat of civilization. Every single day, somewhere on this planet, machines like these are tearing into the earth. They work in temperatures that would kill an unprotected human in minutes. They lift loads heavier than jumbo jets. They operate for decades without ever leaving the hole they were born in. And most people have never heard of them. Today, we are going inside 5 of the greatest machines ever built. Not just their specs, though those are staggering. We are going inside their anatomy. Their components. The engineering decisions that made them possible. And the men and women who operate them at the edge of what is physically possible. This is the world of giant mining machines. Giant excavator, mining pit, heavy machinery, Bagger 293. Bagger 293 panoramic close-up bucket wheel rotating crawler tracks operator cabin. Low rumble of machine, bucket wheel mechanical hum, track movement sound. Bagger 293, largest land vehicle in human history. 14,200 tons 96 m tall 225 m long. Built, 1995 Tachraf, Germany €100 million cost. 18 buckets times 15 cubic meters each 21.3 m wheel diameter. 16.56 megawatts electric 12 crawler tracks. Let us begin with the undisputed king. The Bagger 293. Built by the German industrial giant Tachraf in 1995, this is not just the largest mining machine. It is the largest land vehicle ever constructed. Period. Let those numbers sink in. 14,200 tons. 29 times heavier than the Statue of Liberty. 2.5 times heavier than the Great Pyramid's largest stone block. If you stood the Bagger 293 on its end, it would tower over Big Ben. The machine stands 96 meters tall, a 30-story building on tracks. It stretches 225 meters from end to end, nearly the length of 2 full-sized football fields placed back to back. The bucket wheel alone, the business end of this monster, is 21 meters in diameter. It carries 18 buckets. Each bucket scoops 15 cubic meters of earth and rock in a single bite. That is roughly the volume of a large dump truck, per bucket, every few seconds. Now here is where it gets truly mind-bending. The Bagger 293 was not assembled in a factory and delivered. It was built on site, at the Hambach open-pit coal mine in Germany, piece by piece, over 5 years. The cost? €100 million, in 1995 money. Adjusted for inflation, that is over $200 million today. And once built, it can never leave. The Bagger 293 is too massive for any road, any bridge, any transport. It will live and die in the same mine it was born in. Visual, blueprint sticker plus part close-up sticker overlay on footage. Every single day, 24 hours, the Bagger 293 moves 240,000 cubic meters of overburden. To visualize, that volume would fill an Olympic swimming pool. Every day. For 30 years. The machine has moved enough earth in its lifetime to fill the Great Pyramid of Giza over 100 times. Visual, cutaway diagram sticker showing 12 track units. All of this weight, 14,200 tons, rides on 12 independent Caterpillar track units. Each track unit is the size of a small house. Each one is independently powered and can pivot. This distributed weight system means the Bagger exerts less ground pressure than a passenger car. Yes, the largest vehicle on Earth is gentler on the ground than your Toyota. All of this power, and it is operated by a crew of just 5 people. 3 operators per shift, 2 shifts per day. They work in an air-conditioned cabin 70 meters above the ground. Fly-by-wire controls. Joysticks. Touch screens. Laser guidance. The electricity, 16.5 megawatts continuously, arrives via a dedicated substation. The cable, as thick as a human torso, snakes behind as the machine crawls at 0.6 kilometers per hour. You could outwalk the largest vehicle on Earth while eating a sandwich. Cat 797F convoy on Hull Road close-up tires kicking dust engine bay operator POV. Engine roar, tire crunch on gravel, air brake release. Caterpillar 797F, world's best-selling mining truck. 623 tons loaded 363T payload 4000 HP. Engine, 20-cylinder Cat C175-20 6 liters. Tires, 4M tall 5.3T each $250,000 per set. Fuel, 1,140 liters/hour at full load. If the Bagger 293 is the king of extraction, then the Caterpillar 797F is the king of logistics. Every smartphone. Every electric car battery. Every copper wire in your home, chances are a 797F moved the raw material that made it possible. 623 metric tons loaded. 363 tons payload. 200 passenger cars. Or 35 adult African elephants. Or a fully loaded Boeing 747. All in the bed of a single truck. Visual, giant tire sticker with specs callouts. What makes this possible? Let us start from the ground up. Each tire stands 4 meters tall, taller than most ceilings. Each weighs 5.3 tons. A single tire costs $63,000. A full set of 6 costs over $250,000. They require nitrogen inflation, not air, because at this scale a tire explosion is less like a flat and more like a bomb. Visual, engine cutaway sticker showing 20 cylinders. The heart of the beast, the Cat C175-20 engine. 20 cylinders. 106 liters. Quad turbocharged. 3,793 horsepower, more than 4 Formula One cars combined. The engine alone weighs 23 tons. It drinks over 1,100 liters of diesel per hour. At full load, it consumes enough fuel to fill the tank of a normal car every 3 minutes. Inside the cab, air-conditioned, soundproofed, GPS navigation, payload monitoring accurate to 1%. The driver sits 3 stories above the ground. A new 797F costs $7 million fully equipped. But for a large copper mine, it pays for itself in under 2 years. Some mines operate fleets of 50, running 24/7, 365 days a year. The truck service life, 50,000 hours before rebuild. At 24/7 operation, roughly 6 years. Then the entire powertrain is removed, rebuilt, and it goes back to work for another 50,000. Our 9800 digging sequence hydraulic close-up bucket scooping loading cat truck. Hydraulic hiss and whine, rock falling into truck bed, diesel rumble. Liebherr R 9800, largest hydraulic excavator. 810 tons 11 tall 42 cubic meters bucket. Made in Colmar, France. Power, 2 times V16 diesel equals 4000 HP. Hydraulic pressure, 350 bar, 5000 psi. The Bagger is brute force. The Cat is logistics. The Liebherr R 9800 is precision. Manufactured in Colmar, France, this is one of the largest hydraulic excavators ever built. Think of it as the world's largest backhoe, with the precision of a surgical instrument. 810 tons. 11 meters tall. A bucket that swallows 42 cubic meters per scoop, equivalent to 12 restaurant dumpsters in a single bite. Every 30 seconds. The power comes from 2 massive V16 diesel engines, 4,000 horsepower combined. Visual, cutaway diagram showing hydraulic cylinders, pumps, fluid paths. But horsepower is not what makes this machine special. It is the hydraulics. 350 bar, over 5000 psi. Enough pressure to cut through solid rock like warm butter. The hydraulic cylinders, each the diameter of a dinner plate, can extend with hundreds of tons of force. Visual, isolated bucket sticker with steel teeth detail. The bucket alone is an engineering marvel. Steel reinforced for rock impact. Replaceable manganese steel teeth, each weighing over a ton. Designed to wear out and be swapped during maintenance. The operator can control the bucket tip with millimeter precision, fly-by-wire controls, laser measurement, computer-assisted balancing. The bucket can gently tap an egg without cracking it, or tear through bedrock without flinching. In a typical loading cycle, 4 to 5 bucket loads fill a Cat 797F in under 2 minutes. In a 12-hour shift, over 100 trucks loaded. 36,000 tons moved by one machine in one shift. BelAZ in snow, 8 wheels turning, engine bay operator braving extreme cold. Twin engine roar, snow crunch, wind howl, engine heaters humming. BelAZ 75710, largest dump truck by payload. 450T payload, world record, 810T gross 4600 HP. Made in Zadzina, Belarus. 2 times MTU 65L V16 engines 5,600L fuel tank. Operating temperature, -60 degrees Celsius to +50 degrees Celsius. The Russians do not compete by the same rules as everyone else. While Caterpillar and Komatsu optimized for efficiency, the engineers at BelAZ in Belarus asked a simpler question: what is the absolute maximum we can build? The answer is the 75710. 450 metric tons payload. The weight of a fully loaded jumbo jet in the bed of a truck. To move this, 2 MTU 16-cylinder diesel engines. Each 65 liters. Each 2,300 horsepower. Combined, 4,600. More power than a World War II destroyer. The fuel tanks hold 5,600 liters, enough to drive a normal car around the Earth. Visual, cutaway showing parallel twin engines, drive shafts, Siemens electric drive. The innovation is in the drive system. Instead of a mechanical transmission, the BelAZ uses a Siemens electric drive. The 2 diesel engines spin generators. The generators produce electricity. The electricity powers wheel motors. This is the same principle used in locomotives and nuclear submarines, applied to a dump truck. Smoother power delivery. More torque. Better fuel efficiency. And dramatically less maintenance than a gearbox that would have to handle 4,600 horsepower. Visual, top-down blueprint showing 4-axle steering geometry. 8 tires. 4 meters tall each. Arranged in 4 pairs. All 4 axles steer independently, giving a 20-meter-long vehicle a turning radius under 20 meters. Tighter than many city buses. The tires are tubeless radial, custom-made, capable of supporting over 100 tons each. The BelAZ was engineered for one environment, frozen Siberian mines. -50 degrees Celsius, routinely. -60, possible. Diesel gels. Oil becomes sludge. Steel shatters like glass. The BelAZ has automatic engine preheaters, battery warmers, heated fuel lines, heated mirrors, heated seats. It can start unassisted at -50 and operate at -60. $10 million per unit. But in the remote diamond mines of Yakutia, 500 kilometers from the nearest town, it is the only machine that can do the job. PNH electric shovel digging cable reel unwinding bucket close-up control room. Electric motor whine, rock impact, cable tension sounds. PNH 4100 XPC, electric rope shovel. 1,500 tons 120T payload 6,000 HP electric. Made by Komatsu, formerly PNH Mining, Milwaukee, USA. Power, 7,200V trailing cable zero emissions at machine. Production, 87,000 tons/day. Not all giants run on diesel. The PNH 4100 XPC represents the future, and increasingly, the present. Pure electric power. Zero direct emissions. 1,500 tons of electrically driven muscle. Unlike hydraulic excavators, a rope shovel uses massive electric motors and steel cables to control the bucket. No hydraulic fluid. No diesel. Just electricity flowing through a cable as thick as a human arm, carrying 7,200 volts directly from the mine's power grid. Visual, cutaway diagram showing hoist motors, sheaves, cables, A-frame. Electric motors have a unique advantage: maximum torque at zero speed. The instant the operator engages the hoist, the bucket moves with full force. No spool up. No lag. This makes electric shovels dramatically faster in loading cycles, 10 to 15% faster than hydraulic equivalents. Visual, close-up of massive power cable on reel. The lifeline of the 4100 XPC is its trailing cable. 300 meters long. 7,200 volts. As thick as a human bicep. It spools automatically as the shovel crawls, a robotic cable management system that prevents tangling and damage. The cable connects to a mobile substation that follows the shovel as it works across the pit. The bucket, 90 tons empty, 120 tons loaded, is suspended from a massive A-frame boom. Replaceable manganese steel teeth. Each tooth over a ton. In a 12-hour shift, 87,000 tons excavated. Enough to fill 240 cat trucks. Production cost per ton significantly lower than diesel, no fuel, fewer moving parts, less maintenance. $25 million. Return on investment, 18 months in a large copper mine. After that, it prints money. And unlike diesel machines that lose power at altitude, a 4100 XPC at 4,000 meters in the Chilean Andes performs exactly the same as one at sea level. Drone mine panoramic truck convoy blast sequence control room workers. Blast explosion, truck convoy rumble, control room quiet beeps. Inside the mine ecosystem. Typical open pit, 2 to 4 kilometers wide times 500 m plus deep. Fleet, 50 plus trucks, 5 to 10 shovels, 10 plus drills. Workforce, 500 to 2,000 workers, 24/7/365. A single giant machine is impressive. But what makes a modern mine truly remarkable is how these machines work together. Think of a mine not as a hole in the ground, but as a carefully choreographed industrial ballet. Pure machine sounds, bagger hum cat engine roar Liebherr hydraulics BelAZ twin engines PNH electric whine fade to silence. A typical large open-pit copper mine spans 2 to 4 kilometers across and descends over 500 meters, deeper than the Empire State Building is tall. Concentric benches, each 15 meters high. Trucks spiral down 12% grades, fully loaded, 24 hours a day. 50 or more haul trucks. 5 to 10 shovels. 10 to 15 blast hole drills. Dozens of support vehicles. All coordinated by GPS-based fleet management, tracking every vehicle in real time, assigning routes, optimizing for traffic, predicting arrival within seconds. The control room looks like NASA mission control. Wall-sized screens. Every truck. Every shovel. Every ton. Blast engineering, drilling holes 20 meters deep, packing precise explosive mixtures, fracturing rock without pulverizing it. Part science, part art, honed over decades. Comparison diagrams, blueprint overlays side by side, scale comparison animation. All 5 machines side by side scale diagram. Subtle atmospheric drone, no voice interruptions. Now let us step back and compare. 5 machines. 5 engineering philosophies. 5 different approaches to the same fundamental problem, how to move as much earth as possible, as efficiently as possible. Visual, full comparison diagram, human car house bagger 293 towering overall. If we line them up side by side, the scale becomes clear. The bagger 293 dwarfs everything. At 96 meters, it is over 10 times taller than the Cat 797F. The BelAZ and Liebherr sit in the middle, roughly 8 to 11 meters tall. The PNH, at 15 meters to its boom tip, bridges the gap. But each machine was designed for a different job. The bagger extracts. The PNH loads. The Liebherr loads, but with hydraulic precision instead of rope mechanics. The Cat and BelAZ haul. Different tools for different tasks, but all part of the same ecosystem. Visual, animated bar chart showing HP comparison across machines. In terms of raw power, the BelAZ leads at 4,600 horsepower, twin engines working in parallel. The bagger follows at 16.5 megawatts, equivalent to 22,000 horsepower, but electric, not diesel. The Cat and Liebherr both sit at 4,000 horsepower. The PNH delivers 6,000 electric horsepower, instantly, from 0 RPM. Visual, timeline 19502030 showing machine evolution. The bagger was built in 1995. The BelAZ in 2013. The gap is only 18 years, but the engineering philosophy shifted dramatically. From massive single-purpose machines, to modular, maintainable, data-driven platforms. The next generation will make even these giants look primitive. Autonomous trucks, electric vehicle prototypes, solar panels at mine remote ops center. Futuristic ambient, quiet electric motor hum. The future of mining, 2026 to 2035. Autonomous, plus 15% productivity, minus 30% fuel. Electric, zero emissions, regenerative braking. Remote ops, thousands of km from the mine. The machines we have explored today represent the pinnacle of 20th century engineering. But two revolutions are reshaping mining right now: autonomy and electrification. Autonomous haul trucks are already reality. Since 2020, mines in Australia, Chile, and Canada deploy driverless versions of the CAT 797F and its competitors. GPS, radar, LiDAR, accurate to within centimeters. Never tired. Never mistaken. Never calling in sick. 15 to 20% productivity gains. 30% fuel reduction, because computers drive more smoothly than humans. Operators sit in remote operations centers, potentially on another continent. Rio Tinto runs its Pilbara iron ore mines from Perth, 1,500 kilometers away. One operator monitors 5 trucks simultaneously. The Uberization of mining. Electrification accelerates rapidly. Battery electric and hydrogen fuel cell haul trucks in development. Zero emissions underground. Regenerative braking recaptures energy on downhill hauls. Dramatically lower maintenance, electric motors have a fraction of the moving parts. Some mines now run on-site solar and wind, extracting the minerals needed for the energy transition without contributing to the problem. The machines of tomorrow will be smarter, cleaner, more productive. But they stand on the shoulders of giants: the Bagger, the CAT, the Liebherr, the BelAZ, the PNH. These machines taught us what is possible. The next generation will teach us what is sustainable. Operators in cabins, maintenance crews, family photos, community shots. Soft human elements, voices, tools, community sounds. The men and women behind the machines. 5-person crew runs the world's largest vehicle. 12-hour shifts, 14 days straight in remote mines. Generations of mining families. Behind every one of these machines are human beings. The Bagger 293, the largest land vehicle in history, is run by just 5 people per shift. 2 shifts a day. 10 people total. They climb 70 meters of stairs to reach their workstation. They spend 12 hours in a climate-controlled cabin, guiding a 14,000-ton machine with joysticks and touchscreens. The CAT truck drivers work 12-hour shifts, 14 days straight, then 14 days off. They live in mining camps hundreds of kilometers from the nearest town. Their children grow up knowing dad or mom works on the big trucks. Some families have 3 generations of mine workers: grandfather on a rope shovel, father on a haul truck, son in the autonomous control room. The engineers who build these machines spend years on a single project. The Bagger 293 took 5 years to assemble on site, in the German winter, piece by massive piece. The BelAZ was designed in Belarus, tested in Siberia, and now operates from the Arctic Circle to the Australian outback. Behind every spec sheet and every technical diagram is a team of people who dedicated years of their lives to pushing the boundaries of what is mechanically possible. These are not just machines. They are monuments to human ingenuity. Steel cathedrals to the belief that nothing is impossible, given enough time, enough money, and enough stubborn determination. Montage: all machines, sunrise, operation, sunset, drone pullback revealing mine scale. Machine sounds fading out, silence, single truck rumble, fade. End card. Thank you for watching, plus subscribe button plus. Coming next, deep sea mining robots. From the slow unstoppable march of the Bagger 293, crawling at walking speed through the German countryside, to the BelAZ 75710 roaring through Siberian blizzards at -50 degrees, to the silent electric precision of the PNH 4100 XPC in the Chilean Andes. These machines tell a story. Not just about engineering. About human ambition. The refusal to accept limits. These machines move mountains. Literally. Every smartphone. Every electric car. Every building. Contains minerals that were once buried a kilometer underground, extracted by one of these giants, hauled to the surface 1 truckload at a time. The next time you see a photo of a mine, do not just see a hole in the ground. See the ballet of 50 synchronized trucks. See the operator 7 stories up guiding a bucket with millimeter precision. See the autonomous trucks of tomorrow driving themselves through darkness, guided by satellites and AI. This is the world of giant mining machines. And it is more incredible than most people will ever know. Thank you for watching. Which of these giants impressed you the most? Tell me in the comments. Subscribe for more stories about the machines that power our world. I will see you in the next one.